Um, Good afternoon, sir. So today I'm going to discuss on my lab assignment 2B. After big problems here and there, but then finally I could come up with a, nice code. But still, there is some part that's not working because of the image. Maybe the image is very very restaurant. It seems that it shows warning, and some of the image couldn't appear because of some rasterization. So uh, based on my experience. So I've tried a few times and so many times, not a few times, so many times to actually come up to do well in the 2B assignment. So I've done pretty okay. The code, I can understand the code a bit. So I'm going to try to do it again. So I think I really need to reconnect it again. Always there's a problem in terms of my connection here because I'm using my data. So sometimes it's very slow, sometimes it's fast, sometimes it's slow. So my data is also going to finish. So I think it takes sometimes you see there's so many, so many inactivity. Your session will expire in 5 minutes. So it's a normal thing. So I'm going to start again with my lab test 2B. So the first thing that we need to do is basically I'm going to go through the question because before we do anything, we have to go through the question first before we answering the question. So basically, my lab assignment is on variance, as you know, my last lab assignment 2, the last one is on variance. So actually here, a variance is to measure the contrast of an image. Basically, I've given 30, because sir have given me 30 sample size of image. All are very, some, yes, low contrast, some high contrast, but basically most of it is high contrast. Yeah, you can see there's so many colors into it and looks very nice pictures. Just that some pictures couldn't appear in my project because I'm using online. So there is a few difference between those who are doing in MATLAB. So manually lower the contrast of an image using ImAdjust in MATLAB. So basically I have to use ImAdjust to actually lower the contrast. So before this we have already done with sharpening an image, how sharpening and also smoothing part also we use ImAdjust. So same thing here, we're going to use ImAdjust. And now we are using t-test function in Microsoft Excel to check whether the variance of the two class, which is high contrast and the poor contrast. We're going to check both of them. The variance means the difference. Variance is basically the difference. So we're going to see the contrast difference. And then I'm going to see whether the image is, how much is the difference, whether it is significant or not significant. So basically there is two. Okay, to actually test this using t-test function to check variance between the poor and the good one, we can check using how to say check using difference. I mean the good one minus the poor one, and we can see the difference. If the difference is very high, that means that it is not significant, means the difference is very the significant difference from each other is very high, means yeah, very high. And if it's low, then it's low. So yeah, we're going to see that. And then the objective of the experiment is basically to measure the contrast of an image, and we're going to compare using variance t-test function to actually compare with the between variance between the good and the bad contrast. I mean good and poor, okay, not bad, poor. And then the output of the t-test we're going to see late at the end. And then what's the conclusion? So we're going to see and we're going to conclude at the end. So basically I'm going to go to the code. So I'm going to go to the code. Okay, for the code I'm going to start with so basically sometimes we have typed so many things, and we want to make sure that these things are uh, all these things are not, we just clear it, we don't want anything else. Okay, we have already done with the clear all. And then yes, we have to start with listing. We're going to list the files, list all the files and directories. Okay, we're going to list all the files and directories. And then yes, for listing all the files and directories, we're going to use dir. Okay, so I think to use dir, I think we should dir we're going to see the directory. dir means directory. So let me tell you what is meaning of dir um, by actually going through this. I'm not able to, my this thing, what? Okay, my Google, okay. Okay, I'm going to go and check what is dir. Okay, actually, basically, dir is basically to list all the contents. What happened? Okay, dir MATLAB. Okay. Okay, see, list folder contents. Basically, you can list all the contents, including folder, the subfolders, and then all the files from the directory. So basically, for those who are using MATLAB, they're going to use directory in terms of where they save the pictures from. So where they save, so from the starting to the end, everything will be listed. So for me, I am not able to actually use dir directory here because you see here directory is actually list files and folders in the current folder. Okay, okay, this thing the thing is always appearing. Okay, so that is what is meaning of dir. Basically list files, folders, and then match with the name, and they will come up with all these things: name, the date, um name, date, all the data, the is director, whether they are whether they are a director or not directory. So many things that can we can see all these things. So whether the name, folder, they will come up with date, bytes, is directory or not. One is the name of the folder, zero is the name of the file. Basically, this is a logical class where one is the name of the folder. If you see, later, I'm going to show you whether it's one or zero. When it's one, then you can see, oh, it means it is a folder. When it's zero, then it's known as file. And then the date num is basically modification date as a serial date number. So basically the date that we modify the image or whatever it is. So it should be in double. And then the size of the file in bytes is very important, because sometimes like for example in my Octave, why the some images is not appearing is because of this size of the file in bytes. Basically, when you see each file in the size of each file in our laptop or wherever it is, it will be in bytes form. So like for example in MATLAB, since it's an it is a software, so it is able to actually get all the images, and then even though the images is a very big bytes, I mean very big in size. But for me in Octave, it doesn't take that much, because bigger sizes will not allow, because it will give me limit. That is why some of the images will not be appearing for me. So yeah, date as well. So all these things, so it's very important. So in terms of the code, in terms of the code, we're going to do this. So the directory, where our directory here is basically we're not going to put anything here, because normally directory is where we're going to put where are the image is located in our PC. But for me, I'm not going to do that, because mine it's not reading. So what I'm going to do is I took all the images that I want, that all the 30 images that I supposed to have is all inside here. So I actually drag those files and upload it here. Okay. So yes, we will name this as file list, because it is in a list, file list. Basically, all these are files. So file list equals, okay, equals. Okay. So before that, we also have to put as image. Okay, to actually put in the name of the directory, we are not able to do that. Okay, so I'll put it this way. Okay, I'll put it this way, and then yes, of course, we will go next to total files. Total files. Okay, total files, where it will be equivalent. It will be equal to um, number element. So NUML is basically number element. And then here it will show me the file list, because I'm going to call this file list here. If you see the file list over here, I'm going to call this here. So yes, it has to be the same, because if you see the L in the between is big, so it has to be big capital letter. Okay, so I'm already done with the listing part. I already list all the files and directories. So basically image directory is equals to nothing because I'm not going to call anything from there, and image dr also I'm not going to path it to something. I'm not going to do that because everything is already here. And total files is equals to number element file list, because number element is basically how many images that I'm using, that how many things are actually inside the file, the list of the files. So I'm entering it, and I'm going to start with the next part, which is on looping part, to actually read the image. Because I have to do this to read the image is because it's very important, because to read the image, I only have to read images that is in JPG, which is yeah, of course, JPG. I have no idea what is JPG stands for. JPG is the standard format of an image. Okay, actually JPG, PNG, SVG, all these are standard formats of an image. So now we are using all JPG. So to make sure that okay, again, due to inactivity, session will expire in 5 minutes. Okay, so it's always like that, because my data is very slow. Clear all, because I'm not going to wait before that. Okay, we'll save it. Okay, why I'm doing the that's what I'm saying. So we are using is JPG file, so it's easier for me to actually drag it, because now we have we also have all those we have m.m file, like my file here .m, there's 2.m file here, and I have 2 folders also inside here. Later I'm going to show you all that. So to avoid that, to avoid later in the to actually play with the variance and the contrast, we shouldn't choose this. We only choose JPG file. So that is why we have to use loop. So I'm explaining each and everything where for to loop to read the image. So I need to start with some with the for first. Okay, I'm going to start with for loop, which is I as usual equals to 1, and then I'm going to put this where I'm going to put total files. So I'm going to call all the total files here. So total file is the number element. So number element file list. So how many are the elements you will bring to total file, and total files will be here. So there'll be 1, 2. Okay. There will be 1 to 30 files. Should be 35 because 30 images we're putting in. So and then we start with if. Okay, so this part is very important, where I'm just, as I told you, we are using this to actually read the image only. To read the image only, we have to use since we are using file list. So I'm going to use this. This is meaning of not. Okay, if you see my file is wrong, so it should be file list. That's to follow exactly. Okay, file list, and then I have to put I. Okay, I dot isdir. Okay, what is meaning of isdir? Okay, I'm going to do this. I'm going to run this. I'm going to run this file after I've done the loop. Okay, after I've done the loop, and then you're going to see what is the meaning of it. Is empty. Okay, why I'm using is empty? Let us see why are we using is empty. As I told you, is directory is basically, one is the name of the, because we're having 2 folders inside, and we're having 30 files inside. So there is like 30 files and 2 folders, including also we have another 2 more folders files, which is on our MATLAB. So there are so many things. So to avoid that, to avoid this, all the not directly types of, we don't want folder here, we don't really want to call folder. So that is why we're using isdr. So it means that we don't want that. We are not, that means the symbol of the, the symbol of the worm like that, that means it's the one, we don't want that. Okay, why I actually came here is because I want to show you what is meaning of is empty, because I need to no I have to prove you what is meaning of is empty MATLAB. Okay, actually, because this is compatible to MATLAB, so basically you need to know. So is empty is returns logical true 1 if A is empty array and logical false 0 otherwise. It means that it has one dimension of size 0, for example 0 by 0 or 0 by 5. So basically this one will return me true if A is an empty. So if is empty A, it means that thing is empty, means it's empty, means it's not it's not in a JPG format. Therefore, that's why we put there the not the what's that called, the worm thingy. So that this worm thingy. So let me complete this so that it's easy for you to understand. Okay, it's easy for you to understand where I will be using this. Okay, I'm going to show you why I'm using this str find. Str find. Okay, str find is basically to find strings within other strings. Basically, the string is inside another string. So to find string inside another string, so we use string find. Str is basically string. Okay, string find, and then yes, of course, we have to put this inside here. We will take this whole thing and put it inside here. Okay, we will put it inside here, and then we don't want name. Okay, we don't want name. So okay, we don't want name, so we put this. So it has to be this. So yes, of course, we have done with this. So now if you see, this bracket is actually for this, but we need to put another bracket. So we're going to put another bracket here, the closing bracket. See, if the closing bracket is for this, and now we need to put another closing bracket is for this. So we will have altogether 3 brackets. So altogether we have done. So there shouldn't be any syntax error here. So we don't have to put because this is condition based, we don't have to put semicolon. So and then we enter. So now we are done with loop for to read the image. So now we're going to end this. Let us run this because we didn't run from just now. We need to run, and I'm going to show you why. So for this for is this end, and this if is for this end. So I'm going to make it to shin. Wait, okay. So okay. So we are done with this. Now we're going to run this. Save. Okay, the connection is lost, so I have to wait for some time. Okay, now the connection is night, and then we're going to run this. Okay, if you see the total files here is 34. Okay, why it is 34? Supposedly it should be 30. But why is it 34? I'm going to say why. Because 30 is for the files of the image, because we're going to put 30 images. All the images are here with me. These are the image. So there are altogether 30 images has been given to me. So I've already put all that inside here. So there's 30 images plus 2 folders. There'll be 32, and there's another 2 more files, which is the files that I'm looking here. I'm using here, which is assignment2b.m, and there's another file here. If you see on my script.m, so there's 2 files here. So that is why it's 34. So we are done with that. Now we're going to go and see the file list. As I told you just now, we're going to see file list. What is file list basically, right? So file. Okay, it has to be the same. Sometimes, you know, the list L should be capital, as I told you. Enter. So if you see, there is 34 times 1 struct array. So there's, as I told you, there's 34 files and folders all together here. But so I'm going to say, the first thing I'm going to talk about is the name. So what we're going to do is we're going to talk about the name now. File list dot name. Okay, if you see all the names of the files, the folders, everything is already here. If you see all the file names, big thumbnail, design principles, bamboo forest, beautiful autumn scenery, wallpapers, all these things is already here, including the folders and including the script. See, for example, my script.m, as I told you just now, I have one script here, and then there's another one on assignment 2b, which I'm using now. So those things are also included here, and there's two. This dot here is actually basically the subfolders, the folders inside here. And now we're going to see file list. Okay, see, it should be capital again. If not, it will be wrong. Is directory. Enter. Okay, if you see, all the things are all 0, but there's 2 1 because this is considered, as I told you, 1 stands for folder and 0 here is for file. So basically I have altogether 32 files and 2 folders, so altogether 34 lah. And same thing, if you want to go and see you can even go and see for date, bytes, date num and stat info also can. All these things is also available, but I don't want to go that because it's not really important for that. Okay, we are done with that. So I think I've already explained on the file list. Okay, image directory is just empty because I didn't state anything there. And then this answer is 0, so it's nothing. Okay, we are done with that. Okay, next we are going to go further. We're going to go further one by one step where we're going to talk about reading the image. Reading the image or read image. Okay, so for reading the image, we're going to use img. Okay, img, so I'm going to tap this. Okay, I'm going to put it here. img equals, okay, I'm read. So basically we're going to read the image. So when we're going to read the image, im is for image, so I'm read. Okay, so I'm going to put this, and inside here there'll be another one more bracket, this bracket, the square bracket, and then I'm going to take what I'm going to read. So basically what I'm going to read is actually this one, the image directory, what is inside the image directory, and the file is name. So I'm going to talk about the name. So I'm going to list the name. Control C, and then I'm going to bring it here. Okay, I'm going to bring it here. No, just this. Okay, to make it okay. So this is what we want to see. So basically here I'm going to read the image from image directory. The file is name only, all the names of the files. Okay, so we are done with that. Enter. Okay, here what are we going to do? Because since just read only, there's no point. We're going to show. I'm sure. So because we're going to visualize, or to actually the best word to be used is verify. So to need to verify, we need to use img. I mean, I'm sure is basically is going to show you, and okay, this, and then title. So basically we're going to use title. So what are the title we're going to use is basically this one. The same thing we're going to use here. Okay, the same thing we're going to use here because we're going to see the same title. Control C, Control V. Okay, so I'm going to show you the title. So basically I'm going to read this image, and then I'm going to show this img. I'm going to call the entire, I'm going to call the entire thing to image, then image I bring it here, and I title it as this, the same thing. This is basically the title of the file list name lah. So what if, for example, this is 1456709 dash big thumbnail dot jpg, the same thing will be appearing here. So what I'm going to do is I'm going to save this, and I'm going to run this because we are almost, we are before we're going to run this, because there's 30 images, we cannot make it all just like that. Maybe we can use pause for 1 second. Okay, pause for 1 second, one time, for 1 second most probably. So I'm going to save this file, and then I'm going to run this. So make sure it's okay. Here the total files has a mistake. Okay, what is the mistake in total files here? Total files here, assignment 2, line 7. Okay, line 7, total files. What is the mistake here? Okay, see, the mistake is f, the small f. It should be smaller f. That is what the capital, and the smaller is very important here. Okay, now I think shouldn't be any problem. Okay, now there's no problem. So it's just that sometimes this thing will always there's a problem between this. Sometimes the seconds is just running because I'm not able to pause it. I don't want to pause it. Let me show you all the pictures, because some pictures are not appearing here. So easy for you to see lah. Easy for you to see and see some pictures are there. So every time I have to add 15 minutes so that it will, because the time limit given here is only 15 minutes. I always add 15 minutes, add 15 minutes. So that if I add, because 30 images is quite a lot, so I will have to add that so that, see now the connection has gone. This is what always happening to me. So out of time. So what are the images that I can find is only until here. These are the images that I can find. Never mind. I'm going to show you the images until there. Okay. If you see, this is the image as given to me, and then this is the name of the image and .jpg. The entire thing is already there. And okay, let me show you this. All the images that so far that I already come out. Okay, my video, yeah, I put it beside them. Okay. Okay, see, there's color contrast thingy, and then we have this. So looks so nice pictures. So the exact pictures is given here. Riya Sharma Award, Nick Ishak Putra. All these images, the images that basically that I got. Actually, there supposedly should be so many images. Some more, there's some more a lot of images, but because of my connection, this is what happens. Never, but anyway, this is what happened. So basically, I've shown you a few outputs here. Okay. Okay. So okay, and I just want to tell you this, as usual, warning. Because of some images couldn't appear here because of Rasterized plot. As I told you, the bytes. If you see, the maximum allowed length is 10. How many? 100,000. No, thousand. How many? How do you call this? 1, 2, 3, 4, 5, 6. I think it's 1 million bytes if I'm mistaken. So it's gone beyond that 1 million bytes. So if it's gone beyond the 1 million bytes, it will definitely cannot, because you don't take this thing, don't take unless if it's using MATLAB, maybe it happens. So yes. Okay, so I've shown you how I read the image. Why I cannot it does okay, I'm going to close this thing because this thing is too, this thing also I have to move it this side. So we're not going to use this anymore. No, we're not going to use this. So I'm going to bring this here. Output is very important. And this part also very important. Okay. Output is also very important. Okay. So I think it's very clear for you to see. And then after that, after reading, I'm going to do some other part, which is I'm going to use after reading is we're going to do what is that called? Conversion. Because if you see here, after we read the images, we're going to see the conversion between original and also not the gray level. We're going to make it to gray first, so that to see whether to see the contrast. Because RGB, if RGB is basically red, green, blue, where the pictures in color, so it's very difficult to see the contrast. But when when you see it is in gray, I mean black and white gray, so it's able to see the contrast. Okay, so that is why we're going to use the contrast. So we're going to convert first. Okay, I want to make it these things all look okay. Okay, I'm going to, before that I'm going to put we're not going to use this anymore. So okay, this one should be here. Control X. Okay, Control V. Convert RGB to gray. So we're going to make it gray. As I told you, to make it gray, it's better to make it gray to see the comparison very well. So we're going to use I'm gray. I'm gray here. Okay. So we're going to use I'm gray here. Okay, we're going to use I'm gray here, and then To use IM gray, we need to use IM gray RGB. So we're going to use this formula. Okay, let me explain the part. Okay, why are we using IM gray? Because we need to make it gray. I mean, we're going to change it gray to RGB to gray. And IMG here will bring this image into here. So this image will bring here, and the process is RGB2 gray. Okay, let me see what is meaning of, let me show you what is meaning of RGB2 gray. RGB2 gray, yes. So we're going to see what is the meaning of it. Okay, convert RGB to color map to grayscale. So basically, we're going to make it to grayscale. That's the difference. So that's the conversion function for conversion. Okay, so yes, we have done that, but then it's not the end. We have every time when we do something, we need to verify. So to verify this, I am going to put my subplot. So that I want to show you why I'm going to put subplot. Because I'm going to show you. I'm going to show you that it has to be in the first. It has to be on the first one. First. What do you say? On the first row. First row. On the first. How do you say? Altogether there will be one row and two columns, and it should be in the first place. So this is what subplot means. Okay, it should be in the first one row, two columns, and in the first place. So that is meaning of subplot. And then I am show. I'm going to use I am show. Okay, what I'm going to show is I'm going to show IMG gray. So basically, we're going to see IMG first. We're going to see the normal real image first before we actually seeing the gray level. So we're going to compare. When we want to compare, we want to see both together. So that is why it has to be together. So IMG, and then yes, of course, we need to put title. I think I put title at the below here, so it's easy for every. No, I put it at the side because later we need to do some comment. So I think I will just put it the side. Okay, title here. What are we going to do? Title here. So original image. So basically, this is the original one. Okay. Now we're going to see for gray level. So I think we need to see for gray level. To see the gray level, we still use subplot, which we will bring to the next part. So we're going to see it together. So this will be 2. We're going to, so this means in the one row, 2 columns, and in the second one, in the second box. So it should be the second part, and IMG. So now what we're going to do, we're not going to see IMG, the normal one. So we're going to see the gray one, the one that we have already we have changed to gray level. Grayscale, yeah, grayscale. So here will be gray scaled image. Okay, it should be grayscaled image. So now what are we going to do? We're going to run this. Okay. But to run this, there's so many images. Again, we have to use pause for 1 second. Or else this thing is very complicated. We cannot. Okay, pause. Okay, so I'm going to run this. We're going to see what happens. Save this. I'm going to run this. I hope it works. Because since, you know, I have to add lah again the 15 seconds, or else it will not appear all, because there are 30 images, which is very a lot. So I have to make sure that, see, all these things, the one in this color, the brown color, this one all means cannot appear. It don't want to appear because of raster. The how to say, we can say the pictures are very the I don't know how to say that. Maybe the pictures are very contrast, very high contrast, very high resolution, very rasterized. 10, now 9. There's so many pictures, so of course it's like that. We have to wait for some time. Okay, again I have to add until the end. Some pictures that sir have given me is very beautiful, like this, so nice pictures. Very beautiful because it's very nice photography kind of pictures. I don't know whether it's real or what, but nice. Some very nice. The colors very nice, but I don't know why sometimes it don't appear. So I feel very bad that because I know I have a lot of problems, sir. Because always there's something that is a problem for me. Yeah, but it's working. See, see, it doesn't complete. Mm, too large. It cannot take. Never mind. So I just want to show you whatever that I have right now. Okay. Can make it big, so respected. So if you see there's two types of image where you can actually see the original image and so the gray level. So like this crayon looks very nice. I think I like this is very nice picture. So you can see the gray level and the original one, there's so much difference. The eye very nice, so you can see there's an earth inside the eye, a very contrastic color over in the eye, and when you see here it's gray and black and white, this combination of colors. So that is what grayscale means. So this not so much difference, but you can see here there's purplish and here it's already grayish, dark gray here. So yeah, so it's all this. I think I've proven this part. Okay, this one is just now one. Okay, so yes, I'm done with this part. What is this? Are you sure you want to copy this file without? No. Cancel. What is this? What is this? Okay, I don't know what is that. Okay, done with this, let us move further. Okay, now since we have already do conversion from RGB to gray, we have to move it to the next part where before we moving to next part, every time the one that we don't need, we should actually comment it because we're not going to use this anymore. So just comment it, and we don't going to use we're not going to use this anymore, so we just comment it. Yes, of course, we're going to use the next part where we're going to lower the contrast. So basically now we're going to play with the lowering and the high contrast and good contrast. So for that, I'm going to put command lowering contrast, or you can say compare contrast, lowering contrast. Okay, here we're going to use we're going to use another formula here. I mean, not formula, basically what are we going to do is poor contrast. So I'm going to use img also, gray poor. Okay, gray poor, and then I'm going to convert this. What is the formula for this is IM adjust, because we're going to, as I told you, we're going to, for this we're going to use IM adjust to actually lower the contrast. So we actually now we are answering for B. Okay, we're going to answering for B. I'm adjust. This is a formula. So I think I told you I'm adjust, basically image adjust. How are we going to adjust? What are we going to adjust? This is should be the function. So when function, this should be the input. What are the input inside? So the input here we're going to adjust is img gray. This is the input that we're going to use to adjust. Okay. Okay. So we are done with that. Now we need to do subplot. So to make sure that this thing, every time when we do, we have to verify. So we need to come up with this subplot. Yes, since we already blocked that, so we don't have to think about it. We can just use this, or you can just copy paste. So it's easier. We don't take much time. So Control C, and then you bring it here. Okay. So now this part, we're not going to use command. Okay, for this part, we're going to use two. The first one, we're going to use gray because we're going to compare what gray and gray. So where this gray will be the high contrast, good contrast, or you can see high contrast. So I'm using here high contrast. High contrast. High, good is all the same meaning. So there's no such thing as high or good. What is the difference? There's no difference. The same, only high, good. Okay. Now we're going to copy this whole thing again. Control C and then Control V. Okay, now we're going to talk about, okay, I'm always making sure that the, everything's in the straight form, because later then when I want to do revision, it's difficult. So here I'm going to talk about poor. So just now was I'm gray. I'm gray is basically the good contrast. When this one is poor contrast. So that's the difference. We're going to check, we're going to display this. Pause. Oh, sorry, we should not do this. There's no any this thing yet. Okay, so now we're going to save this, and we're going to run this, whether it's working or not. We're going to see whether it's working or not. I think it's working, so it should be fine. See, say high contrast and good contrast. Later I'll show you the entire image. I'm going to show you the how good contrast and bad contrast different. We're going to differentiate. We're going to see, or we're going to compare actually. So whether this function is working or not. So every time I have to add 15 seconds, because the time given, I mean the limit of the time given to me is it's 15 minutes only. So I have to every time increase 15 minutes. Okay, see, add 15 seconds. So 15 minutes plus 15 seconds, sorry. Okay, we're going to wait until the thing stops. Okay, there's so many pictures more on, so we have to wait. Sometimes some pictures not generating, so I think if not mistaken, there's a few very last pictures when it's generating. So now see, this picture was not just now. There's no this picture, but now got, because see the what's that called, the how the inter the what's that called, this how do you call, what do you call it, the resolution of the image is very now becoming low, so that's why it's like you can see so few images that which don't appear just now already appeared now. See, these images all that never appeared before this. So I have to wait until, okay, 15 seconds. Okay, it's almost going to end. So this time is okay. So I think this is the last images, as yes, it is the last image. So you're going to see the image, you're going to see the contrast. Okay, see, this is high contrast, very clear. When it's come poor, it becomes very, very dark and not so clear, not so nice. If you see high contrast looks so nice. So when it comes poor contrast, it's very, the pictures becomes very thick. So you see very thick, but this is actually very high contrast. So this is considered not poor contrast. This is considered very high contrast, because we didn't even change the values. So this is all like considered to be very if you see the images are all very strong, so means you can see the images very, see, compared to this is very you can see very highly contrast. Actually this is supposedly wrong. We should not use this. Instead that we should use this. Okay, so for this part we have to change this I'm gray part, where we're going to change this to, okay, 0 1, because 0 1, we're playing with 0 1, and then we're moving it forward, which is this one, 0.3, and then 0.7, 0.3 and 0.7. Okay, okay, and then Okay, so now we're going to play it again. So now you're going to see it is really poor contrast, because just now it wasn't poor contrast. Okay, what was the mistake? 0, 1. So there's a mistake here. What is the mistake? Is basically there is no this comma. So now shouldn't be any problem. Okay, there shouldn't be any problem. So I think it's working. See, can see the poor contrast. There's okay, there's a few images only. So you can see this is considered poor contrast. Just now was too high contrast because we didn't adjust with the values. So now you can adjust now. I've already adjusted. So if you see these images, you can see the contrast is very poor. So there's a difference between here and this. See, this is a bit dark, very you see the camera can be seen very clearly, and this one the camera is already dull. The pictures becomes very dull, kind of beautiful. Some certain pictures, when you take photography, this type of pictures will be accepted, which is looking very nice. When you print out, it's very nice compared to this. But some people, sometimes we don't really like this. For this type of pictures, they don't seem to be very nice. But this one is very nice because you can see the water very clear. So that is what the images are. Okay. Okay, so I think I've shown to you, like just now we didn't put this value. We're supposed to put this value. This value is very important to actually make it the poor contrast, because just now when we use just I'm adjust means it will adjust and make it even higher contrast. To make it a very poor contrast, because just now I was very wrong, because should be high contrast, even higher contrast the next one, but now only it's the poor one. Okay, so my mistake. So I think I didn't know what is the mistake is all about. Okay, now after I'm doing lowering contrast, we have to go for the next part. Okay, before that we have to put all this what is it called, comment. Okay. Okay, so now we are almost going for the last one, where we're going to see we're going to call about the compute variance. So basically our main part is here is about variance. Okay, we're using t-test function to count variance between two images from the good and the bad contrast, the good and the high, I mean high and the poor contrast. Okay, I think I'm going to change this. I'm not going to use high or poor. I'm going to use low. Okay, low contrast. Like just now, should be high and low. Not should be high and low. Yes. Okay, so now I'm going to do calculation for variance. Calculation on variance. Okay, for this, I'm going to use the formula called IM image var. So to calculate variance, we're going to use image r var. How to calculate? Sorry, all capital. Sorry. How to calculate um variance in MATLAB. Okay, to calculate variance in MATLAB, we have to use MATLAB var, the word var. Since we're using image, so we use image var. So that's the thing. Okay, see, this is what we're going to do. So var returns a variance of elements of A along the first array dimension. So we're using A. So for here, we're going to use image. So it'd be capital V and then close with small r, var. So what are we going to use? We're going to use J1. Okay. um okay, we're going to use j var before that we're going to assign it here over here at the looping part, before the looping part over here. Okay, now we have for image gray over here for gray, and now we have to use for poor. Control C, Control V. So since this is first column, so this will be the second column. J is considered as 1, so J will be the first row. So this part we're going to use poor. So every time when it goes, we have to calculate the variance. We need to use J equals to J plus 1. So every time it will bring to the next part. So this is basically looping. So for example, J equals to 1. So 1 will add it to it, and then it will bring to another one. 1 will be added to it, and it will bring to another one. So it's something like that. So plus 1. I don't know whether I'm explaining it right or not, but I understand how it works. So so yeah, that's the thing. So I actually understand how it works, but then I don't know how to explain the J part. I think what I've explained is just correct. So J is basically J is equals to 1. So when 1 plus 1 is 2, and then when it's got 2, so when J got 2 up there, so 2 will bring you back. So 2 plus 1 is 3. So it will be like looping. So that's what I know, because there are 30 images. You have to loop to get all the 30 variants. Yeah, I think so. I managed to answer the J part. Okay. So always remember that to do variance, basically it has to be it has to be assigned to 8-bit integer. So it has to be double. So always remember that it has to be always double. So you have to put another bracket here. So when another bracket becomes another bracket here. So double, because we assign this as, okay. So we are done with that. Last but not least, we have to actually state up here what I mean which the line for the variance. Okay, actually image what is image var, so that I mean what I mean how many image var is until which part. So that means altogether there are 30 images. So we have to make it in two columns. Yeah, two columns. So to get it in two columns, we have to state how are we supposingly we have to keep the data. How do we call the data? For example, if you want to press on image where image var, entirely the data will appear in the form of two columns, and all the data will be there for all the 30 images. So that's what it means here. So we have to put like image var, the same thing as we put down there. So it's equals to zeros, 30 and 2. So why 30 here? 30 images, 2 is 2 columns. So that's what it means here. Because we want the images to want the images at the end point, because all the time it goes, it will end it when it comes when you go to sec 2 j plus 2 plus 1 3, and then you go after 3, and then automatically the third one will appear in the form of 30, all the 30 images and 2 columns. So that's what it means there. So we are done with this part. I think we're almost done to the end. Control I mean we are save this, and we're going to run this. Is there any problem? I think there shouldn't be any problem. It's just fine. It's working. So it's working, and then now we got the image for where. So just now we got IMG. IMG is just nothing. If you want to see the gray level, all the gray is 255, and all the gray poor is 179. So that is the thing. And then we're going to see the difference. So if you see all together, we have all the data, and then you see image variance, that is 30 times 2, because we have 30 images and it has to be times with 2. That is why it means here 30 times 2. Okay, so what I'm going to call this, I'm going to see, we're going to verify this. Every time we have to verify the variance. Always remember the V is capital, enter. So you see the values, all the values has been displayed. This is for the first image, the good one, and this is the poor one. See the good one and the poor one. So you can see the difference here itself. All the poor ones very high. All the good ones, sorry, all the good one, the high ones all very high. But when you see the low one, it's all very small. So you see this is 5,000 and this is 871. So it's very low in for those poor one, and it's very high for those higher ones. So I think from here it makes sense. I think it's right. It's correct. But anyway, we still have to prove the t-test part. We still have to answer this question, this t-test part. What is t-test and how, what is the output of t-test? T-test is basically the difference between the variance, difference between the high and the good one. So we're going to do that. Actually, I already brought this to the Excel. If you see the images is already in Excel. It's already in Excel. I already brought it to Excel because because it's going to take a lot of time to actually bring me here, because I have to, when I try to copy paste, it takes time. So one by one. So I think I've already okay. The thing is appear. I thought the thing is lost. Okay, we should take the okay. So if you see, all this is being copied. Okay, I didn't even put on my own, so everything is being copied. So if you see, this is the good one and this is the poor one. So now we're going to test for t-test. Okay, actually I want to show you how are we going to test t-test. To test t-test, we're going to put equals. We're going to come up with a function, but to get the function, we need to start with equals t. What are we going to do? We're going to do t-test. So t dot test. And for test, we need to put the first array. What is the first array? Our first array, we can actually type it here, or we can just drag and drop. So I'm going to type it like A2 until, if you see, my values is until 31. So it's yeah, it's until 31. So I'm going to put A dot 31. Or you can just do this way. You can drag it also until 31. Okay, you can do this. And then dot okay, no, not dot, it should be comma array 2. So for array 2, if you see, you have to follow this thing. It's given here already for our guideline. It's already given. So you can take here this part dot no, it should be this, and then which is on B 31. So if you see, it's until here. So until 31. So I think it's right. So and then we have to put another comma. Okay, this part we have to do test using one-tail distribution. We have to use one-tail distribution. And then for type is because we're using two, we didn't use two equal variants, we're using different variants. And I mean, we have pairing it because basically from the same image, so that's why we are pairing it. Okay, and then we're going to close this with this, and then we're going to press enter. So you see the values is already there. So you can actually bring this and you can drag this until 31, and all the values is already displayed. Okay, so I have no idea why is this. I have no idea why, but if you see the difference between here, some of it as very high, all of these have negative 0, 0.5, 0.7, so not so much difference, very less difference. T-test is basically the difference, you know. So you see the less difference, the negative 13. There's no much, not so big difference, all exponential. And then if you see all these is 0.22, that is also, so certain images, so from here what I get to know is certain images has very, very much difference, and certain images have a very big difference. The probability, we're going to see the probability of some certain images when you compare with the good one and the bad contrast one, you can see them, some has big difference and some has very small difference. So when what's the conclusion now? So now we have already done the output, we already got the output, we already know what is t-test, we already perform each step, we already designed the experiment, we have done with the objective. But now the conclusion part. So we have to start with, since the result shows that, therefore we can conclude that. So we're using this sentence to actually conclude this. So we're going to conclude this way. Since the result of the t-test for certain images is high, therefore certain images has very low, or you can say a very slightly I mean when it's high, then the slight the difference between the images is very very low. Am I right? So if I'm not right, yeah, I'm right. So the how do you say this? Since the difference between the good contrast images and the bad contrast images is very low, therefore the there is very different, I mean very slightly different significant. When it's very high, therefore there is no significant difference. That's the difference. When it's very high, there's no significant difference. When it's very low, then it has slightly significant difference. So from here, there's a few images where this type of images which have exponential part, where have a very uh I mean very less significant difference. So therefore the comparison between them is very low. So this part, when they have I mean very there is difference, so it should be low. I think I'm I think, yeah, I think I've made the output clearly. So yeah, I think I've made the output clearly. So I think I need to write it here so that to make sure I'm not blabbering. Okay, so I think I'm going to delete this. Okay, like this. Um, Since, so we're going to copy the whole thing here. Control C. I'm going to make the conclusion because I really need to make the conclusion. This is what they want. This is one of the requirements. Okay, since the results shows low difference between the high contrast and the low contrast, therefore we can conclude that if you see here, this part, significant different from each other. So less significant different from each other. So this is the answer. At the same time, there is also certain images, since the results shows that high difference between the high contrast and the low contrast. Therefore, we can conclude that there is less, sorry, this time should be no. When we have high contrast, I mean, we have a high difference between the contrast and the low contrast, there is no significant difference. So this is making sense actually. So if you see, if it's a big, I mean, if you see the difference is very small, then basically you can see the dust difference lah. If you see the high difference means there's no significant, there's nothing. You cannot see any difference between that. Okay, I think, yeah, this is the thing. This is the answer. I'll make it big. So basically this one, low and less. When it is high, then it is no significant difference. So this is the difference. So if you see, there is two types of image. Sometimes some images have this, some images have that. So I think I heard you do some verification. And thank you so much, sir, for listening to me. And I will submit the code and as well as this what's it called, code and the link of the video to you by today. Thank you so much, sir. Thank you very much for listening to me.